So yesterday, I did an experiment where I applied a lot of heat, like over 1,000 degrees, concentrated on some different samples of wire. Several samples of car audio grade power wire, and a couple samples of welding wire. And Flex Whip, and this other one is Windy Nation. Flex Whip and Windy Nation welding cable. Anyway, someone was asking me what the name brand was on that. I don't know. That's it. The point is, there's essentially two different types of jackets here. In order to make a jacket or an insulator be resilient to pretty much anything, it has to be stiff. So welding wire is fairly stiff. I mean, it has some flexibility, but compared to car audio wire, it's very stiff. So in the world of car audio, you're looking at a situation where you need to move power from here to here. It needs to run through the car, in panels, under carpet, things like that. Whereas most of us in the SPL world actually run it under the car. But I digress. The soft, flexible insulator is sought out, or is needed for that ability. It's hard to work with, thick jacket, hard jacket welding wire. And that's the reason why the market shifted from welding wire originally, that's what we were using, to this purpose-made wire, because it was easier to work with, easier to handle. Now, here's the thing. Welding wire is made a certain way because it has a purpose, right? You're taking two leads and creating a dead short for an extended period of time. And during that time, when you've got that dead short, you've got a sacrificial piece of metal that you're heating up into a molten state with a dead short and fusing it to some other metal to join it all together. And whenever you're creating a dead short as part of the normal operation, that puts the wire under a lot of heat. That copper inside those leads is going to get very hot. And that's the key. It's going to get hot. So what does the insulation on that wire need to be able to handle well? Heat. I mean, you think about it. You're going to be heating this wire up to crazy temperatures over and over and over and over again. The last thing you want to happen is for the insulation to start shrinking up and pulling away from the ends and turning into a liquid goo. And then so that your power and ground leads can melt together into a glob, and that wouldn't work. That's why you need a jacket that doesn't care about the temperatures that it's going to reach. It's logical. Now, think about this, right? We're not done yet. So, we know that the welding wire is designed to be able to not fail under the condition of an extended dead short continually day after day for years. Audio cable would absolutely not work in that environment. It would do that. If you guys watched my last video, you know exactly how this goes. It's not good. Now let's think about what's going on in a vehicle. You got your battery, you got your power and ground wire, or your power and the entire vehicle is a ground wire. Run it from point A to point B. It's set up to conduct power from the battery, the alternator, battery, to the amplifier, to the ground, back to the battery in a loop. Under normal operation, with the proper wire size, it should never get hot. There should be more than enough conductor there that you should never get it heated up to a high temperature. Even running next to hot components in the engine and other things, you still should be maintaining at below the temperature rate, the temperature range that will destroy the shielding around the wire. Under normal circumstances. Now, what causes a wire to get hot in a car audio scenario? Outside things. You know, like I said, hot exhaust, hot engine, or using an undersized wire in the situation where you're pulling way more current through it than you should. That can heat it up as well. And that would be a problem. But under normal circumstances, if something has been working for a long time, it's probably going to continue to do so because it's already been exposed to the conditions. So why would one want to have a very high heat shielding on that wire? Well, let's pose a couple of problems that might come up in an install. Assuming that you've already got a stable system, right? It's capable of carrying the current you need to run the amplifiers without ever getting anywhere near close to hot enough to cause a failure of the insulation. Hypothetical. One day, you're at the gym or you're at the wherever place. It's something. You put something in your vehicle that you normally don't have, and it pinches a wire. Okay? It pinches a wire. I said at the gym. I don't know why I said at the gym. But it pinches the wire and causes it to become shorted. So you end up pinching a power cable, and that power cable gets pushed up against a piece of metal and shorts out. Now, if you're running a fuse, which you should be, it should blow that fuse. Okay? So assuming that fuse is, let's say a 250 amp fuse, and your wire is, an alt gauge wire, less than, 20 feet long, your total run, probably good, right? You're going to short out. It's going to get hot. The fuse is going to get hot, and the fuse is going to blow. What if your team no fuse? Now, you've created a dead short. That dead short is happening. It's happening. It's cooking. And it's cooking and cooking and cooking and sparking and cooking, right? You're maybe aware of this. You're trying to find everything. You're trying to get to it. You're trying to sort it out. Well, this is the wire you're working with, right? This soft jacket. how much of this is already turned into a puddle and is making connections in every other place now because the wire has got hot, melted through the insulation, and is now burning into the carpet and melting and connecting to the floor and other places. And it's the dead short that you originally had is only the beginning. Now you've got dead shorts everywhere. Now, on a dead short situation, we do know about something that's designed specifically to be able to keep a wire protected in a dead short for extended periods of time. Welding wire. In that same scenario, sparks, loud things are happening. Said individual goes, oh, there's the problem, pulls the thing off of there. Some burned stuff, whatever. Battery's really hot. But overall, the whole situation is probably salvageable. Now, these are rare and unusual situations, and again, the fuse should be able to eliminate that problem. Your fuse should fail before your wire goes into meltdown. Okay, that's the important thing. If you fused properly, if you're fusing the size rated for that wire, then your fuse should fail before the wire, which is essentially not the conductor, but the insulation. If it doesn't, well, if the fuse doesn't fail before the insulation, which insulation would you rather have? Just food for thought. Good times all around.